Welcome to this explainer. Today, we're tackling the basics of motion, distance versus displacement. Let's jump in.
You know, everything's moving. Literally everything. From a galloping horse to a speeding train.
But to really wrap our heads around motion in high school physics, we got to start with the absolute basics.
First up, position. To nail this down, you always need a fixed reference point.
Think about it. You can't measure movement if you don't know exactly where your starting line is, right? And that brings us to a super crucial twist in physics, distance versus displacement.
So imagine an athlete running back and forth on a straight track. Let's track their movement.
They sprint 100 meters forward, then pivot and run 60 meters straight back.
The total ground they covered, that's 160 meters. This is simply their total distance.
But here's the kicker. Their net change in position from the start is only 40 meters.
That 40 meters, that's their displacement. It's just the net change from start to finish.
To recap, distance is the whole journey, but displacement is purely your net change in position. Now, in physics, we group these using two real game changers, scalars and vectors.
Distance is what we call a scalar. Why? Because it only needs a number, or magnitude. Displacement, though, is a vector. It demands both a magnitude and a specific direction.
Vectors care deeply about where you're heading. North, south, left, right, the direction totally matters.
For simple straight-line motion, we just use plus or minus signs to show that direction. Easy, right?
So, can distance and the magnitude of displacement ever be exactly the same?
Yep, but only if you move in one straight line without ever turning around.
Let's pause. If you run a full lap around a track, what exactly is your displacement?
Think about your starting line. If you end exactly where you began, did you really go anywhere?